Hello friends, welcome back to our channel. So in today's video, we will be looking at the prospects and the potential evolution of the incoming tropical depression or perhaps the cyclone over the southern Bay of Bengal, and how it will going to impact the uh, some states of southern peninsula India. So let's begin with the current satellite image, which will give us the idea of prevailing dominant system. Uh, so as we look at the satellite picture, it becomes quite apparent that the southern Bay of Bengal is very active. Convectively, we can see that the clouds are extending from uh, Kerala up to the Sumatra region very strongly, and then we have continuous convective activity uh, over the Philippines, and then we have one more tropical cyclone over the northern Australia near Darwin, and that continue to extend till southwest southwest Pacific. So we zoom out of it, you will see that there is a continuum of system which is extending from Bay of Bengal and going all the way up to southern Pacific. So it is a tens of thousands of kilometer long system, which is a reflection of intertropical convergence zone, which is the typical feature of atmospheric convection during the November-December season. Now we are interested in what impact this intertropical convergence zone will going to have over the Bay of Bengal, and how these Bay of Bengal system likely to spin up or likely to give birth to few tropical systems. So to understand that, let's look at the wind patterns that will give us the idea of dynamical conditions over the Indian region. So let's look at the 850 hectopascal winds. We note that there is a strong cyclonic circulation which is situated just west of Sri Lanka, and then we have one more near Kuala Lumpur, near north of Sumatra, and these two systems uh, are forming together with the broad Pacific twin cyclones, and one more system over the Arabian Sea. Now the problem boils down to which one of these will going to intensify. So, and how these different tropical systems likely to interact with each other. So as far as ECMWF is concerned, if we move in time around 24th of November, the intensification of both Sumatra LPS and then Sri Lankan LPS, both are going to intensify together. But by 25th, again, we see the similar pattern of intensification. The Sumatra cyclone or Sumatra LPS likely to move westwards, and Sri Lankan LPS likely to move eastwards. So they are coming together closer. Now around 26, the major transition likely to happen, wherein the Sri Lankan LPS likely to intensify significantly compared to the Sumatra LPS. And here the major shift in weather pattern anticipated as we move toward 27. There is a massive intensification over just Sri Lanka coast, Now the problem is that because it is forming just near the land, its further intensification is might be limited because of the frictional impact. And also this Kuala Lumpur or this near Sumatra one is also affected by topography. So both are somehow dammed by the topography. But the winner likely to be the Sri Lankan LPS. And if we move around 28th, it will move northwards, very, very close to Tamil Nadu coast. And then 29, it will, both of them will intensify a bit, but this one likely to be bigger compared to the Sumatra one. Now, by 30th of November, it will likely to move northwards, very close to Chennai coast, but unlikely to landfall as per the current expectations. So it will impact the periphery of these systems will bring rainfall over the coastal region of Tamil Nadu. But this is only the initial projections. I'm not quite confident whether it will result in reality or whether it will turn out to be true in reality or not. That we have to see. So now let's have a look on GFS model. So if we look at the GFS, again the similar picture is emerging from the GFS. We have a system which is quite intense over the Sri Lankan region, and then the shear zone extending up to the Sumatra. We have one more LPS, and by 24th, 25th, the GFS is giving a completely different scenario wherein the Sumatra LPS likely to intensify more compared to the Sri Lankan one, and by 26 and 27, both are likely to merge, and the dominant system likely to be the Sumatra one, Sumatra or near the southern Andaman Sea. And by 27, it will likely to move northwards, and it will continue to move northwest up to 30th of November and likely landfall near Odisha coast partially, and then it will turn northeastwards or maybe dissipate. So this is the scenario emerging from the GFS. So the major changes we are seeing in GFS and ECMWF is that the ECMWF is giving the importance to the Sri Lankan LPS, while the GFS giving importance to Sumatra LPS. So if the Sri Lankan LPS intensifies or wins over the Sumatra one, then it can impact the Tamil Nadu region. On the other hand, if the Sumatra one gets an edge, then it'll unlikely to affect the Tamil Nadu coast. So it depends upon which system will going to dominate. So why model are struggling here, in this particular case is that there are multiple systems, and this complex interaction makes it very, very difficult for models to grasp. That is the reason why the forecasts are changing in every single run of the model. So if we look at the icon, now again the similar picture for icon. Currently we have a circulation pattern, and two LPS are quite evident in both all the models, but in icon again the Sri Lankan LPS not able to win. They intensify significantly by 26, but the Sri Lankan LPS both likely to remain of same. I mean, they appears to be of same intensity, and they likely to merge together by 27. So this is also a plausible scenario, but we have to see. And if this happens, then again, impact on partial or marginal impact on western side of Bay of Bengal and eastern part of Tamil Nadu cannot be ignored. So these are so one thing is absolutely certain from these projections that cyclone likely to form, or not certain, rather we have more confidence that a system will definitely going to form. But whether this system will impact the southern peninsula India or not, this remains to be ascertained with the guidance of the future runs. Now, what we can expect from the AI model? So, I mean, it will be quite interesting to look at the different AI models. So let's see AIFS ensemble members. Let's look at the wind patterns from these AIFS, which is the artificial intelligence model ensemble mean. And let's see what the AI models has to offer. So let's select the 850 hectopascal and let's see what they have to say. It is taking a little longer to load. Let's wait for some time. Yeah. So I guess the server is little down, but it can give us the little idea. So again, we see the formation of system near Sri Lanka exactly as seen in ECMWF-IFS. So in terms of the genesis, we are certain that it is likely to follow that similar path. So this is not, now let's again do this. So now you will see this Sri Lankan LPS likely to dominate, and it will intensify, and then it will move northwestwards, or northwards rather. So you will see, so this is common in almost all AI models and in ECMWF IFS. Now let's see if more Pangu weather is also a good model. Now let's look at how and what type of weather it is expecting. See, again in Pangu weather we have similar pattern wherein both of them are intensifying, and the intensification of Sri Lankan LPS is taking place. So it is dominating than the other system. So, and almost following this similar pattern of landfall near the western Tamil Nadu, or eastern Tamil Nadu rather. So two models. Now let's see GraphCast. It is also a great model. So you can also explore it. Now let's Southern Asia and 850 hectopascal. And now let's see what it has to say. Again, it is showing similar genesis over near Sri Lankan coast, and the system again following the similar trajectory as we have seen in other models, and the landfall again near the Tamil Nadu coast, or it is likely just touch and go like scenario. So yeah, so it is also giving the similar mm, patterns. So let's see the Aurora. This is also a good model. Now let's have a look on how what it has to offer. Again, this model is suggesting two systems. The intensification of the Sri Lankan LPS is inevitable in this model as well, and it is also forcing the system to move northwards, and this model is suggesting a low kind of situation but not very strong, and but the impact on Tamil Nadu coast is common in almost all the models. So what is the takeaway from all this analysis? So one thing is an agreement among all the model. One thing that is an agreement among all the model is that the depression or cyclone will definitely develop. There are discrepancies regarding where the cyclone will exactly form. But if we look at the data-driven models and compare them with a physics-based model, then it turns out that the physics-based model are not in agreement with each other. They have problems. Some are intensifying the Sri Lankan LPS, while some other are intensifying the uh, Sumatra LPS. But as far as data-driven model are concerned, there is no discrepancies as far as the location of genesis is concerned. All of them with varying intensity are triggering genesis near the Sri Lankan coast. That is same in all the AI models. And one more important takeaway from the AI model was that almost all of them are forcing a cyclone to move northwards, parallel to Tamil Nadu coast, very close to Chennai, and perhaps the landfall near North Tamil Nadu and southern Andhra Pradesh. So it is not just one model, but all the AI models are suggesting similar pattern. And also ECMWF-IAFS, which is the physics-based model, also now converging to or getting very, very close to these physics with AI-based model. And surprisingly, these AI models have been showing similar patterns well before the physics-based model was even able to capture this type of pattern. Even physics-based model struggling to get this uh, I mean, they are not able to get the exact genesis location till date. So I guess we must trust the uh, that data-driven model, but for the intensity, we need to rely on the physics-based model because the data-driven model usually creates a smooth field, so intensity may not be very clear. But for genesis location, they are the best. And this is my takeaway from the analysis of this particular system. Of course, it might be different for a different system. So I cannot comment on other. I am not making a general assessment about the which data driven or the physics based model likely to work. This is just for this particular system. It turns out that the data driven model perhaps are behaving much more consistently compared to the physics based model. So we will update after 24 hours as we have more latest data available from the new model runs. Till then, we can keep watching how the convection evolves, and we can also look at other agencies forecast like Japanese, like Canadian, IMD, and many other agencies, UK Met Office. So there are other agencies which can also be uh, uh, considered while making any uh, conclusions regarding the genesis and landfall of this particular cyclone. So thank you very much for watching. I will see you in the next video. Till then, bye bye and take care.